Hello students, in this video you will be learning how to construct an angle bisector.
In this next construction, we want to construct something called the angle bisector. Now, angle bisector, just as the name implies, it means I have a certain angle which I want to divide into two equal parts. So in this case, we want to construct the angle bisector of angle ABC, where angle ABC is 60 degrees. So to begin doing this, I will need an angle that is 60 degrees. We can construct this very easily. Just draw a line. We can use the protractor. Now there is actually an alternative method to obtain a perfect 60 degrees using the principle of equilateral triangle, but that is a lesson for another day, right? So here we have an angle 60 degrees measured using the protractor, and I'm just going to call this angle A, B, C. Right, now let's proceed to create our angle bisector. To create the angle bisector, we just need a compass. Open it up to any length, something reasonable, not too big, not too small, something easy to handle, like this will be fine, right? And I'm going to draw an arc like this from the pivot to do this. Okay, by doing this, I have two more intersection points that's created along the two legs of the angle, original angle. Now, to facilitate our discussion, I'm just going to call this point E and point F. To continue creating the angle bisector, this time round, without changing the length of the compass, I'm going to put the pivot at point E and draw an arc across in this manner. Keeping to the same length, put the pivot now at point F and join them in this manner, right? So I've created an intersecting pair of arc over here, and if I were to join this intersection over here back to our original angle B, like this line that we have just drawn is the angle bisector. To facilitate discussion, let's going to call this point Z. Remember, our original angle ABC is actually 60 degrees. So now, if I were to use my protractor, and I were to measure the angle ZBC, is 30 degrees. Similarly, the angle ABZ is also 30 degrees. We are successful. And this is our angle bisector.
So here's another look at the final product. As we can see, the original angle ABC is bisect. Okay, it was 60 degrees. Now I have a pair of 30 degrees angle ABZ and ZBC. Now, since the radii of the arcs are the same, what do you think is the name of the quadrilateral BFZE? Take a look at the diagram again. BFZE. You may pause the video to think about it if you need to. Very good. It is a rhombus because the length BF is equals to the length of FZ, which is equals to the length of ZE and equals to the length of BE. So, with that understanding, are you able to explain why BZ constructed in this way is the angle bisector? Think about it. What are the properties of the rhombus we are aware of? That's right. The diagonals of a rhombus are angle bisector of each other. Good luck.